This study looked at the effect of walking speed and ankle load on the joint kinematics and arm swing in children with and without Down syndrome. Previous studies have shown that challenging children with Down syndrome to walk faster than preferred and with an ankle load has shown promising adjustments to their gait pattern, such as increasing step length, decreasing step width, and improving general muscle activation. However, the joint kinematic and arm swing control strategies employed to make these adaptations remain unknown. We assessed the peak flexion and extension, lower body joint angles, and anterior, posterior, and medial lateral amplitudes of arm swing. The subjects included 12 children with Down syndrome and 12 age and sex matched, typically developing children. Data was collected on a Vicon motion capture system as the subjects walked 10 meters down a walkway at their preferred speed and at a speed described as fast as possible without running, as well as with either no ankle load or an ankle load equivalent to 2% of their body mass. We then evaluated peak angles during the relevant phases of the gait cycle. Around toe off, children with Down syndrome had less peak ankle extension. When the ankle load condition was added, peak ankle extension was lower. In addition, the children with Down syndrome also had less peak hip extension around toe off. Around mid-stance, children with Down syndrome walked with less peak knee extension. When walking faster, their peak knee extension reduced. These results suggest that ankle, knee, and hip extension during stance may need to be targeted during interventions. During the swing phase, children with Down syndrome increased peak knee and hip flexion when walking faster than preferred. The typically developing children showed these same adjustments. Therefore, challenging children with Down syndrome to walk faster might encourage increased hip flexion during swing. When looking at arm swing, speed and load independently, there was an increased amplitude in the anterior, posterior, and medial lateral directions, but no group differences were found with arm swing, indicating that the children with Down syndrome adjusted to the conditions similarly to their typically developing peers.